Hello friends, Namaste. Let's talk about spatial data entry and preparation. Before talking, I would like to talk about modeling landscape. The modeling landscape has three dimensions: conceptual model, logical model, and physical model. The conceptual model, which deals with the real world, logical models of across all systems, and the physical model models individual system. Conceptual model is a data modeling techniques which models entities or objects and their relationship in the real world. It's a highly abstract fact with no details and easily understandable, and like it will model entities, its attribute and relationship, what the system should contain. Logical model, which deals with the how the system will be implemented irrespective of DVMS, database management system. It will add more details on a conceptual model, which will include attributes, primary key, and it will be a user friendly. And similarly, the finalize of logical model will generate physical data model. It will explain how the system will implement with database management system. According to the database management system, how the system will interact, and it will talks about entities, which refers to some logical similar to logical model. It includes entity, which refer as a table, and attribute refer as a column, and it will be a database compatible and easy to mapping schema and transfer of schema. Overview of this, we particularly know the conceptual model, which is the world of discourse, which contains rivers, sand, ontology, semantics of a real world. After that, it will contains digital representation models, which we represent that land. If it is in use in different purposes, it could be residential, industrial, then we will represent it as a raster or vector data model and different categories. Then it will be further analysis, which is how far from A to B, or what distance is Ram's house from Sam. Such analysis can be performed, and after that it will be visualized in a visualization model with cartographical rules, and it is termed as a cartographical model. So it will represent in a 3D model or 2D map or simulation. Spatial data input consists of a map, satellite data, digital data, tabular data, or soft ideas or written ideas, or any ideas which could be key coding. And tabular data and digital data can be transferred, and satellite data can be scanned, and maps can be digitized. Altogether data capture, and they will be edited and cleaned for our purpose. And if the projection system is not defined, we will define the projection system or reproject it in a standard or global projection system such as WGS84, and edge matching and layering in a different layer to show that particular GIS database or map overlay in a different layer. This was given by Haywood in 2007. And another is the way of capturing data is like primary data capture or direct spatial data capture. And the data which is captured directly from the environment is known as primary data capture. It is done through field surveying or through the using of instrument. It is directly captured from the environment or the ground. With the primary data, the core concern is that it should be known how it has been captured, by which process. Another parameter of any instrument used. Similarly, rigor, which quality requirement were observed. We have to know that which quality it is in, the data is, and what instrument was used, and what's the process to observe or capture the data. Remote sense imagery is usually not fit for immediate use as a various source of error and distortion. So there should be, we should correct them radiometric and geometric correction should be taken, should be considered before using it. For an image, no interpretation of reflectance value as a thematic or geographical characteristic has taken place. So we should convert or translate the reflectance value in a certain thematic variable, and we refer it as a raster. In practice, it is not always feasible or possible to obtain spatial data by direct or field observation. This might affect by different factors such as cost, availability of time. So we can use previous data which can be also fit to this project. So we should know the ability of data by clearinghouse or geo portal. From there we can find out the data is available for that particular location, so that field observation is not required. Direct field observation is not required. Similarly, indirect spatial data capture. Spatial data can be sourced indirectly, known as secondary data. This could be a vast amount of existing data can be found, which could be in a digital or analog format. Digital can be existing satellite image, database or GPS data, and analog it could be in a report, map or image, and these or even we can find in a different online sources, different website or clearinghouse or geoportal. From there we can capture this data. These data are derived from existing map through scanning, or data digitized from satellite image, processed data purchased from different capture frames or international agency. Data collected for other purpose and converted to the GIS purpose are termed as a indirect spatial data capture or secondary data. And raster conversion, scanning of map, aerial photograph, document, etc. Important scanning parameters are spatial, spectral, and temporal resolution. These three things should be considered, like spatial, smallest feature that can be detected by a satellite sensor or display in a satellite image. Spectral resolution, ability of a satellite sensor to measure a specific wavelength of electromagnetic spectrum. Finer a spectral resolution, narrow will be wavelength for a band or channel, and temporal resolution, times between images, satellite images. These three things should be considered during a direct spatial data capture as well as indirect spatial data capture. Digitizing. A traditional method of obtaining spatial data is through digitizing existing paper map. It is a process of converting or encoding information in a digital format and digital representation. There are two types of forms of digitizing. On one tablet, another one is on screen, and these both are manual. And in tablet, the original map is fitted on a spatial surface, the tablet, while on screen digitization, a scan map, which is georeference and projected on a screen. Therefore, it will be easier to comfortable as well as zoom in and zoom out operation on screen, easy of editing compared to tablet. And tablet, in terms of tablet, is typically used to trace, digitize. We will enter a coordinate information through digitizing tablet and digitize through a black light lit, allow all feature on the map to be easily observed and reduce our eye strain. And mapping optical scanning system automatically capture map feature text symbol in a tablet digitization. This functions lock a coordinate system on the control point. Digitize data control points on the map have non-coordinates. We will provide at least 3 control points, but preferably more should be digitized to allow a check on the positional error made. Is even semi-automatic as well as automatic digitization, depending on how the operator interaction is required. If vector data is distilled from this process, a process is called vector